Hi, buddy. Your host Chandrakant is back. Today we are going to solve question 162, that is find peak element. Okay, so let's go through question once and then we'll see how we can solve that problem. Okay, a peak element is an element that is strictly greater than its neighbors. Yeah, given a zero indexed integer array nums, find peak element and return its index. If the array contains multiple peaks, return the index of any one of the peaks. Got it? You may imagine that nums of -1 or nums of n is equal to minus infinity. Got it? In other words, the element is always considered to be strictly greater than a neighbor that is outside the array. Got it? You must write an algorithm that runs in log n time. Okay, so let me show you one example what this particular question wants to say, that like there will be a graph, means a array, not actually graph, but I'll be representing that array in terms of some curve and all. Okay, so this is something, this kind of graph will be formed, like one element is here, next element is here, another is here, another here. Likewise, if you see, there are multiple elements in our array. Okay, now this you can do like this. Okay, so yeah, you can basically number 1 2 3 and so on in y direction, and you can number this to some, let's say, 4 3.2. Right now we are just dealing with integer, but just for representation I have mentioned that value. Okay, so this is something uh, will be given as input. Now what we need to return, means here if you see, this one is peak element, right? This one is one of the peak element, this one is one of the peak element, so we need to just return the I guess index of the peak element. I'll just check whether we need to return the index or what. Yeah, return its index. So we need to return the index of these elements. So zeroth index, first index, second index, so either 2 3 4 5, fifth index, 6 7 index, right? 8 9. So any of the 2 5 7, any one of them will be the answer, right? Now let's see if there is a scenario like you have a array that contains number like 2 2 2 3 3. Means in this case, if you see, the graph is like comes like this, goes this way, continue this way, right? These are 3, these are 2. Now here if you see nothing is there, means you can assume that no element is there, means this one is the greater element. Here if you see, there is no peak element, because if you see, it says somewhere, it says, what is the peak element? Huh. An element is always considered to be strictly greater than a neighbor that is outside the array. That we got. Where is the, huh, if array contains multiple peak, what is peak element? A peak element is an element that is strictly greater than its neighbor. Okay, so this was first line only. So if you see, if we compare this index, okay, so it is greater than from this side, but it's equal. So this can't be a peak element. Will this be a peak element? No. Will this be a peak element? No, because this one is smaller. From this direction is smaller, and from this direction it's equal, right? So this is also not peak. Now this way, this is greater, but in the other way it's equal, so that is also not a peak. Equal, smaller. So none of the element in this example is a peak element. So how we are going to solve that issue now? Means we need to go back in question, and uh, when I read this particular question for the first time, means when I read this question, I got to know that this will be not solvable in this scenario. So instead of mentioning here, they have mentioned like here, the adjacent element is not equal. Means our example will be never like 3 is adjacent to 3 only, 2 is adjacent to 2 only. So that is never the case. Okay, so that's why it guarantees that some peak element will always present. How it is guaranteed that some peak element will be there? Because if you see that a number is here, let's say, and another number will be either smaller or bigger, right? With respect to this, if you see, next element is not equal, it's bigger, right? So this can be, you can write as 1, 2, 3, means these are not equal, right? And these two elements are also not equal. It means this will somewhere form a peak element, means if there will be no element in the left of 2, then this could be peak because it is greater from this side as well and greater from this side as well. So it guarantees that there will be always one peak element will be present. Okay, now coming back to the question, how you can find that peak element, right? You can just iterate through whole array and check if that particular element is greater than its two of the neighbor or not. If it is, then you can surely return that index because that will be contributing to peak element, and we just have to return one index of that, means any one index which is contributing to peak element, right? Now that if you do linearly, means checking each element whether that is greater than its left neighbor and right neighbor as well, so that will be of time complexity order of n, means linear time will be taken to do that, right? Now again, there is one more line that we need to find one peak element in log n time. Now what we can do, that's the question, right? So if we think of log n, can we go for binary search? But right now the situation is not like the array is sorted or something, right? But the thing is, let's say if we divide our search space into some point, and if we can able to identify whether we have to go towards leftward direction or rightward direction, then we can surely divide our search space into two half and move our either left or right pointer to towards the other pointer. Means let's say you have left pointer, then you can move it towards right and right pointer towards left, and wherever those will collide we can stop, right? So that is right now intuition, we are not sure whether that will work or not. So what we can do, we can just take this example and run it and check if we can find that stuff or not, right? Let's say we are given nums will be random number. Let's take any random number like 1 2 1 5 and 8, let's say. That is the array. If you see, then 2 can contribute to the peak element and 8 can contribute to peak element because this side minus infinity and this side minus infinity, right? That is the case. Now to solve that out, can we do one thing? We can keep our left pointer here, we can keep our right pointer here. Now we just have to find mid and decide whether we have to jump leftward or rightward, means move our left pointer or right pointer. Can we do that? Let's check feasibility of it. So mid will be this one, right? Now if you see, the mid element is this and mid plus one element is this one. If this one is greater, right, means the right word element is greater, means this can never be peak element, right? So in this case what we can do, we can move our left pointer from here to here, right? Because for sure, means this will be the graph and we are here and we saw that graph is moving towards this, so 5 could be the answer, or the any element which is greater than 5 will contribute to our answer. So we can move our left pointer to towards, means 0 1 2 third index, means move to third index. Okay, what if instead of 1 there is other value, like let's say we have an array of 1 2 9 5 and 8, and you found mid as 9, left is this and right is this. Okay, so what to do now? If you compare this element with this, you can surely say that this is the graph like this. Now, if you are here, it means this particular element can contribute to a peak element or the element which is present beyond this, means this direction, right? So what we can do, if we can move our right pointer from here to here, that will work because we want our search space to be shrinked. Plus, we need to guarantee that in that direction we at least get one peak element. Okay, so let's solve this case ahead and then we'll see for the upper case. Okay, so what will be this case? If you see, now you have 1 2 and 9 as array. Okay, and its index are 0 1 2, and your right is right now here and your left is here. Now mid will be this, right? Now if you compare your mid with just rightward element, so you can see that 9 is greater than 2, means the graph is like this, means you can surely say the element which is at index 2 will be greater, and that can contribute to our answer. So we can move our left from here to here. Now if you see left and right collide, means we can say that this element will be surely contributing to peak element. That is one conclusion right now, but we are not sure. So let's check for other example as well, if that is working fine, if that is giving us answer or not. Okay, so in this case, we checked for 5. 5 is greater, means we can move our left pointer from here to here, right? So our search space will be 5, 8, and left is here, and right pointer is here. Okay. Now, what will be the mid? Mid element will be this one. Now we need to compare mid with next element. Now what will be the case? If we compare and we see that the right element is already greater, means that the graph is in this direction and we are here, we need to go there, means go to 8. So we move our left pointer to here. Now left and right again collide and 8 is answer. So if you see in this array, we have two possibilities. One is 2 and another is 8. So we are successfully able to get that 8 is answer, right? In this case, in the second case, if you see 9 is one of the peak element and 8 is one of the peak element, and we were able to find 9. So you can say that means in log n time, means using by dividing our search space into two half, we are able to decide in which direction we can move, and surely getting one element which is peak element, right? So that is the simple intuition which we need to implement for this particular problem. Okay, yeah. What else? Yeah. One note point here means if you go through till this point, right, you won't be able to figure out whether the uh, peak element will always exist or not, right? So you need to scroll a bit, just a second, scroll a bit, and here if you go to the condition, they have constraint like the adjacent element can't be equal, right? Means nums of I not equal to nums of I plus 1 for all valid I. It means the adjacent element can't be equal, so it will guarantee that our array contains peak element always. Okay, so now let's code that out and see if that will work or not. So what we are going to do, we are going to, let me bring my laptop closer. Yeah, we need left pointer, we need right pointer. What will be the left? Left will be at 0th index and right will be at len of nums minus 1. Okay, now while left is less than right, what we need to do? We need to calculate mid. Mid element will be left plus right by 2. Now, if nums of mid is less than nums of mid plus 1, right? If that's the case, means we need to move towards right, means we can move our left pointer to mid plus 1. So left pointer will be mid plus 1. What else? Else the case will be we need to move our right pointer to which direction? If this is the case, we moved our right pointer to mid index, right? So mid index. Now what we need to return? Return any index, left or right, will give index of peak element. In case of just one element, we have one element that we need to return because left and right will be pointing to one element. We have two elements, means the one which is greater will be surely getting returned. Here you can see, means just two element, 5 and 8. So we moved our left pointer to here. What if 8 will be at this side and 5 will be at this side? If you see, mid is means value at mid is greater than value of mid plus 1, means we are moving our right pointer to here and that will give us answer. So anyways, left and right will be colliding and that will be giving us the peak element. So this code will work fine, so I'll be submitting it. All good. So yeah, that worked. And the time complexity of this algorithm is log n because each time we are dividing our search space into two half. And in one of the video we discussed like binary search, means we can apply binary search in all those problem where we can easily identify how we can divide our search space into two half, and at every point we can decide whether to go leftward or rightward. So that's the case where we can apply binary search, right? Means it is not always necessary that the array needs to be sorted or something, right? And if we talk about space complexity, we just use two variable, three variable, and that is constant, right? So space complexity will be order of 1 and time complexity is log n. So that's it for this video. See you in next video. Yeah, thank you. Bye.